All right, geometry. So this is your 1-8 notes covering perimeter, circumference, and area. So these are terms that you should be familiar with from past math classes. What I'm very, very interested in is this standard GGP7 of using coordinates to compute perimeters and areas. You've done perimeter area in the past. That's fine. We will review a little bit of it. But I'm interested in if they give me coordinates and a polygon, can I find the area and perimeter from a coordinate plane? All right, so that's our goal, overall goal. All right, so let's refresh our memories that the perimeter of something is the sum of the lengths of its sides. It's the sum, okay? Because it is the sum of the lengths of the sides, you're not multiplying anything. The answer will be in units. Now, if they give you units like centimeters or inches, it'll be centimeters or inches, okay? Area, however, is the number of square units it encloses. So area is measured in units squared. So that would be centimeters squared, inches squared. And again, that's because you're typically multiplying two dimensions together. So here are all your formulas for perimeter, circumference, and area. So understand that perimeter and circumference are the same thing. It's just circumference is for circles, right? So circumference is the perimeter of a circle as you look. So if you look at a square and a rectangle, so rectangles are really the first ones you should look at, right? So a rectangle, the perimeter, notice this interesting formula, 2b plus 2h. Again, it's just because opposite sides are congruent. So this is also a b, this is also an h. So you could just add up the four sides. It'll be the same thing. The area is base times height, right? So a square is just a fancy rectangle with all the sides the same. So the perimeter, they call it 4s because you're adding s plus s plus s plus s, 4 s's. The area is s squared because you're still doing base times height, but it's just s times s. And s times s is s squared, all right? And then a triangle also comes from a rectangle. A triangle is just half of a rectangle, right? I could build a rectangle around that triangle. And again, this area would just be half of it. So notice for the perimeter, you have to know the three lengths of the sides. But for the area, you need to know the base and the height. Notice that the height is not a side of this triangle, but the height is perpendicular to the base. So we need to remember that the height must be perpendicular to the base. If you remember that from our construction section, right? That symbol means perpendicular, means right angle, which is right there. And then lastly, a circle. So a circle's two major dimensions are the radius and the diameter. Understand that the diameter is just 2 radii, right? That relationship holds. So the circumference has two formulas. You could do pi times diameter or 2 pi r, pi times 2 radii, because 2 radii is the diameter. I'm a fan of the radius equation because to do the area, you just have to move that 2 to the exponent above the r, and there's your area formula for a circle, pi r squared. Okay? All right, cool. Last on this set of notes here, so we're going to work with some irregular shapes. So it'll be not a recognizable shape. So this area addition postulate says the area of a region is the sum of the areas of its non-overlapping parts. So what we're going to focus on is taking a irregular shape and breaking it into rectangles and triangles. Sorry, this pen with there's a button on the pen. Rectangles and triangles. Okay, and again, it's from these type of figures and our formulas that we can then find the area of the larger irregular shape by adding those smaller areas. All right, so I have an assignment in Delta Math and also in Edgelastic, and I have videos for each. So continue to watch.